Alright, people, look at this equation here. It looks really wrong, right? So what's wrong? Like, how can you add 3 cm to 2 seconds? And how can you say 5 kg is equals to 3 cm? So that's what the homogeneity of physical equations is about. When you want to add two quantities together, then the two quantities better have the same unit, like 3 cm plus 2 cm. When you say that two things are equal, they better have the same unit. Yeah? Maybe like 5 cm is equal to 3 cm plus 2 cm. So how can we make use of this concept? So let's use this as an example here. So this is a formula. You don't have to know what it is. But let me tell you that this is some kind of pressure. P is a pressure. V is some kind of speed. G is 9.81 meter per second square. H is some kind of height. Yeah. Now this symbol here, this Greek symbol is pronounced rho. Yeah, rho. I'm not going to tell you what it is, but by looking at the units, maybe you can make a educated guess as to what it is. So first thing is, we're summing up these three quantities on the left hand side of the equation. That means these three terms must all have the same unit. So pressure, the unit is Pascal. So this term here, half rho v squared, to get overall, right, should have the unit Pascal. So rho gh should also have the unit Pascal. And P naught, of course, is also some kind of pressure in Pascal. Now, what we are interested in is the unit for rho, yeah, the mysterious quantity. So, how do we do that? First, we have already said that we know the units for half rho v squared is actually Pascal. So now let's just work with the stuff in the bracket here, the left hand side of the equation. So half has no unit, so we can just ignore half. The unit for rho is what we are after, so the units of rho. Yeah, I forgot to mention, I use this square bracket to denote the unit of. So when you see square bracket of something, just read it as the units of of that thing. So the unit of v squared is of course meter per second square. Yeah. On the other side, we have the Pascal. But I think we should be working with base units, not derived units. So what is Pascal? It's actually Newton per meter square. Let's open up the bracket here, the square here. So we have meter square per second square. On the right hand side, the Newton is not a base unit. So it's a derived unit. So in base unit is kilogram meter per second square. Yeah, how do I know that? Force goes to m times a. Yeah, force goes to m times a. Okay, now let's tidy things up. The per second square on both sides will cancel out. So what is the unit for rho? Well, we still have the kilogram there. Let's collect all our meter squares, our meters. So looks like we'll end up with per meter cube. So the unit for rho is actually kilogram per meter cube. That looks like some kind of density, right? So yeah, rho is actually the density of a fluid. Yeah, by studying the units in the equation, we can actually make a very good guess. All right, that's all. Ta-ta.